Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're going over the Chapter 3 test review, I guess, for other years. But also, this is going to be 3.5 to 3.8 for the current year. But depending if I use this video in the future, just know this is the test review for Chapter 3, basically, okay? But this is kind of a lot of problems, and there's a lot of concepts. I thought it would be useful to go through every single problem, make sure you guys feel comfortable with everything, and we will be in good shape. So let's get into it here. It says solve the following equation. So for number 1, we have x plus 9 equals 13. Well, to solve for x, we're not going to guess what number it is because that's not what solving is. We need to actually solve. We need to undo adding 9. How do we undo adding 9? What's the opposite of adding 9? Well, we're going to subtract 9 from both sides. So x is going to be equal. 13 minus 9 is going to be 4. So like I've mentioned many times, you probably could have guessed that x equals 4 just by guessing what number goes in the blank, but that is not solving, and that's not going to aid you very well from Algebra 1 onwards. So it's very important that you know how to solve problems and not just guess what the numbers are, okay? All right, number 2, x divided by negative 4 equals negative 5. How do we undo dividing by negative 4? Well, we do the opposite, which is multiplying by negative 4 on both sides. And those negative 4s are going to cancel. We get x is going to be equal to, that's going to be negative 5 times negative 4, which is positive 20. All right, moving on. Negative 3x equals 33. When they're smushed together, what operation is that? That's multiplication. How do we undo multiplying by negative 3? We're going to divide by negative 3 on both sides. So x is going to be equal to 33 divided by negative 3 is going to be negative 11. We'll zoom out so you can see all the answers. All right, we're going to get harder as we go here. Let's keep moving along here. We have number 4 is 2/3 x equals 6. When you multiply by a fraction, we could divide by a fraction, right? By 2/3 on both sides, but dividing by a fraction is the same thing as multiplying by the what? What's the shortcut? It's the same thing as multiplying by the reciprocal. What's the reciprocal of 2/3? Well, you flip it vertically, it's going to be 3 over 2. So we're going to multiply both sides by 3. That was bad, 3. By 3 over 2. These are going to cancel. We're going to get x is equal to, put the 6 over 1 to multiply straight across. 6 times 3 is 18. 1 times 2 is 2. So x is going to be equal to, 18 divided by 2 is 9. You could have also reduced here and gone 2 goes to 1, 6 goes to 3, and 3 times 3 is 9. If you're comfortable with that, otherwise just go ahead and multiply straight across and then divide at the end. All right, number 5, 8 minus 4x equals 28. So we have we need to get rid of that 8 and that negative 4 times x. Do we do the division first, or do we get rid of the multiplication first, or the positive 8 first? Usually we do the opposite of PEMDAS, and we want to get rid of addition and subtraction first. You could also write this as negative 4x plus 8 equals 28. So the first thing we're going to do in this problem is we're going to subtract 8 from both sides. We want to get that negative 4x by itself. So we're going to subtract 8 from both sides. And now we have negative 4x equals 28 minus 8 is 20. And now we have negative 4 times x equals 20. How do we undo multiplying by negative 4? Well, we divide by negative 4 on both sides. So x is going to be equal to 20 divided by negative 4 is negative 5. All right, last problem on this row. Negative 4 times x plus 1 equals 20. First thing, I've not been doing our steps for this too. What's the first thing we always look for when we're solving equations? Starts with a D. We want to look if we can distribute. Anything to distribute here? There is. We can distribute the negative 4 to x and negative 4 to 1. You could also divide both sides by negative 4 if you wanted to start, but I like to distribute usually. I think it just makes things easier in general. So what is negative 4 times x? Well, that is negative 4x. Negative 4 times positive 1 is negative 4 equals 20. Now we need to solve. So anything else to distribute? No. Any like terms to combine? Also no. Now we need to move stuff around. We need to take care of addition and subtraction first. We want to get this negative 4x by itself. So how do we do that? We need to get rid of that minus 4 by doing the opposite, which is going to be adding 4 to both sides. We get negative 4x equals 20 plus 4 is going to be 24. And the last step to solve for x, we're multiplying by negative 4, so we need to do the opposite, which is dividing by negative 4 on both sides. And we get x is equal to 24 divided by negative 4 is negative 6. All right, pause the video if you need to catch up a little bit. All right, moving on. Number 7, 3/4 x minus 5 equals 8. Anything to distribute here? No. Any like terms to combine? No. We need to get this 3/4 x by itself first. So how do we get rid of that minus 5? Well, we're going to do the opposite, which is adding 5. So we have 3/4 x equals 8 plus 5 is 13. Now, like I said, how do we undo multiplying by a fraction? Well, we multiply both sides by the reciprocal, which is 4/3. 13 over 1, these are going to cancel. X equals, what's 13 times 4? That is 52. What's 1 times 3? That is 3. And actually, 52 does not divide by 3, so this is the final answer you should put. I don't want you to put, like, whatever that is, like, whatever, like, to do the mixed numbers. I don't care about mixed numbers. We don't care about mixed numbers in high school, basically, okay? Just leave it as an improper fraction. That's the most exact answer. You don't want to put a decimal here either, because decimals are rounded usually, and rounding makes it less accurate. So leave it as 52 over 3. That's your final answer, even though that's a little uncomfortable. All right, number 8. X plus 20 equals 9x minus 4. First things first, anything to distribute here? No. Any like terms to combine? No. There are like terms on both sides of the equal sign, but when I say like terms, they need to be on the same side of the equal sign. Like 4 and 20 would be like terms. So there are no like terms here. All right, now we need to move stuff around. We need to get all the variables to one side and all the constants to the other. So I'd probably move the variables first. I'm going to move x to this side over here. And how do I undo that x? Well, the opposite of positive x is to subtract x from both sides. I'm going to do that so I have a positive 8x on the right-hand side, which I like. I don't like negative 8x on the left-hand side. So we get that, minus 4. All right, so now the variables are alone on one side. Now we need to get those variables by themselves. So how do we get rid of that? How do we get that 8x by itself? Well, it's subtracting 4. How do we undo subtracting 4? Well, we're going to add 4 to both sides. So we get 20 plus 4 equals 8x. Last step to solve for x, to get rid of that multiplying by 8, we're going to divide by 8 on both sides. So x is going to be equal to 3. Or 3 equals 8. You can also write it like this if you wanted to. 3 equals x, that is. Either way is totally fine. Okay, number 9. New color, moving along here. We have 2 times 2x minus 3 equals 3x minus 10 plus 2x. First of all, anything to distribute here? Yes, we got the 2 to the 2x and 2 to the negative 3. So what we're going to do is 2 times 2x is going to be 4x. 2 times negative 3 is negative 6. Equals, and we have 3x minus 10 plus 2x. Keep the rest of it the same. Don't skip steps. Anything else to distribute here? No. Any like terms? Yes, we have 3x and we have 2x. Those are like terms. So we have 4x minus 6 equals, what's 3x plus 2x going to be? That is 5x minus 10. All right, now we have variables and numbers on both sides here. We need to get all the variables to one side. You guys want to move the 5x or the 4x? I probably move the 4x just because it'll give me a nice positive 1x over here. I don't like, if we subtracted 5x, we'd have negative 1x. We'd have to do an extra step by dividing by negative 1. So that's kind of messy. So in this case, so all we have to do now to move the variables or the constants to the other side, the numbers, instead of subtracting 10, we're going to add 10 to both sides. And x is going to be equal to 4, or 4 is equal to x. I like to flip the variable to the left. It just makes it more neat. All right, number 10, 6x minus 1 plus 3x equals 4 plus 9x minus 5. Anything to distribute here? No. Any like terms? Yes, on both sides, actually. We got 6x and 3x are like terms. We also have 4 and negative 5. So 6x plus 3x is going to be 9x minus 1. It's going to come along for the ride. Then we have 9x over here as well. And then we have 4 minus 5 is also minus 1. What do you guys notice about both sides of the equation here? They're exactly the same, so automatically, if it's a true statement, it's going to be infinite solutions. Let's solve for x now. We would subtract 9x from both sides. We're going to get negative 1 equals negative 1. Is that true? That is true. So this is going to be what's called infinite solutions. When you get something where everything cancels out and you get just the same thing on both sides, it's going to be infinite solutions. If you get something where everything cancels out and it's not true at the end, that's going to be no solution. All right. Next one, number 11. We have 1/3 times 6x plus 12 equals 5x minus 6. So, what does it look like we should do here with this 1/3? So there's two things we can approach this. It looks like we're supposed to distribute the 1/3 to this, okay? Before you do that, you want to see if it's going to work out nicely. What's 1/3 of 6x? Does that work out nicely? What's 6 times 1/3? That's going to be 2x. And what's 12 times 1/3? That's going to be 4, which actually works out really nicely. So I would distribute in this case. Another thing you can do instead of distributing is, what you could do instead is multiply both sides by 3 and go like this. And then distribute over here the 3 to both of these. But that's how we get rid of multiplying by a fraction. We multiply by the reciprocal, 3/1, right? So in this case, it would work either way. I can show you both ways. Why don't we just do it both ways? Why not? It makes sense. So we're going to do it the way this is. First way we're doing here is we distributed, which is good. So now we need to solve for x. How do we solve for x here? Well, we need to move the x's. I'm going to do the opposite. I'm going to subtract 5x from both sides. And try to do a negative on the left-hand side here. So negative 3x plus 4 equals negative 6. Now we need to subtract 4. We get negative 3x equals negative 10. Divide by negative 3. X is going to be equal to, 10 doesn't divide by 3, but two negatives make a positive. So we're going to get for an answer, x equals 10/3. Do not write it as a mixed number. Those are not appropriate anymore, okay? Let's do it the second way now, too. So we have 1/3 times 6x plus 12 equals 5x minus 6. So multiplying both sides by 3 will cancel the fraction. These are going to cancel. We get 6x plus 12 equals 3 times 5x, 3 times negative 6 is 15x minus 18. All right, I'm going to subtract 15x from both sides. And I get negative 9x plus 12 equals negative 18 minus 12. I get negative 9x equals negative, 30? Divide by negative 9. X is still going to be equal to 10/3. So when you simplify, 3 goes into both 30 and 9, which reduces to 10/3. So either way is totally legit. I would distribute if you can, just to be in tune with what I've been teaching you. But if it's easier to just multiply both sides by 3, do that instead. So, all right, number 12, we have 13.25x plus 24.8 equals 5.25x. Again, we have decimals here, but we don't change the rules of math just because we have weird numbers. All right. So first things first, anything to distribute here? No. Any like terms to combine? No. Now we need to get all the x's to one side. So should we move this, or should we move the 5.25x? I would move this to this side, because if you subtract 5.25x, you're going to have equals 0 over here, and then everything's going to be on this side, and you're going to have to move something over to the other side anyways, so why do more work than you need to, right? I would subtract 13.25x from both sides, and then we get 24.8 equals 8x. And that's nicer now that we have something on both sides. So now we can divide by 8. X is going to be equal to negative 3. Oh, it's negative 8 over here. Sorry. Divide by negative 8. Negative 3.1 is going to be our answer. Okay, so be careful when you don't want to move something that's all by itself on one side usually. Usually you want to move stuff to keep a balance on both sides. Otherwise, you're going to have it equal to 0, which is not the right answer. Okay, moving on. So we've got a couple pages to go. Well, these next ones shouldn't be as long, I hope. So, all right, number 13. We're going to use green. It says rewrite the following equation so that y is a function of x. What does that mean? Well, that means we need to get y by itself. We need to solve for y. So we have 6x plus 3y equals 15. So we need to get y by itself. What's the first thing to get this 3y by itself? Well, we need to get rid of that 6x by subtracting 6x from both sides, right? Even though it's kind of weird, if it were just 6 plus 3y equals 15, you would still subtract 6 from both sides, right? Even though there's an x there too, it does not matter. We're still going to subtract 6x from both sides. So we get 3y equals negative 6x plus 15. Put the x in front, because in chapter 4 that's going to be very important. What's the last step to solve for y? We're going to divide by 3 on both sides. So we get y equals negative 6x divided by 3 is negative 2x. 15 divided by 3 is 5. And there's our final answer with y by itself. All right, number 14, 2x plus 6 equals 3y minus 12. We need to get that 3y by itself. What's the first thing to do to get y by itself? When you get this 3y by itself, so we need to add 12 to both sides. And I'm not going to add 12 to the 2x or to the 6. Which one's like terms? The 6 is like terms. I'm not going to add 12 to 2x. That's not going to make sense. I'm going to flip it around now. Maybe not. We'll do 2x plus 18 equals 3y. What's the next step to solve for y? We need to get rid of that 3, so we're going to divide it with both sides by 3. And now I'm going to flip it around, put y equals. Does 2 divide by 3 nicely or no? So I'm literally going to write 2/3 x. I'm going to put the x off to the side and put 2/3 in front. Plus, what's 18 divided by 3 going to be? That's going to be 6. And now we have y as a function of x. And we have y equals 2/3 x plus 6. And there's our final answers. All right. Numbers 15, solve for h in the following formula. Similar kind of thing. We're going to try to get h by itself, and it's just going to be kind of weird because we're going to have leftover variables that are not going to go away, and that's okay though. So we have v equals LWH. What's happening when they're all smushed together like that? Well, that's multiplication. So how do we undo multiplying by LW? We're going to divide by LW to get that h alone. So we get h is going to be equal to, these are going to cancel, is going to be equal to v over LW. All right, number 16, we have v equals 4/3 RH. We need to get h by itself. First thing I would do with these kind of problems is to fraction bust. I would multiply both sides to get rid of that 3 in the bottom by multiplying both sides by 3. So now we're going to have 3v equals 4RH. These 3's are going to cancel. And now we have 4RH equals 3v. How do we undo multiplying by 4r? Well, we're going to divide by 4r on both sides. So h is going to be equal to 3v over 4r. And there's our final answer. Even though it's kind of weird, it's still the right answer. All right, 17 through 20 are percent and unit rate problems and stuff. So let's go ahead and get into that. If it costs, to solve the following problems, be sure to follow directions and label when necessary. If it costs $9 for 12 cookies, find the unit rate. All right. Well, unit rate, what we literally do is we divide the first number by the second number. So I'm literally going to take, even though it's kind of weird, I'm going to divide 9 by 12 because that's what it's telling me to do. 9 divided by 12 is 0.75. So what's the unit? It is dollars and cookies, right? So it's going to be $0.75 or 75 cents per one cookie. And that's your answer. That's all you got to do. Divide the first number by the second number and put your units. You can type 180 words in 3 minutes. Find the unit rate. Well, again, first number divided by second number, 180 divided by 3, and that's going to be equal to 60. And what's our units? Well, it's going to be words per 1 minute. 60 words per 1 minute. The second number always needs to be a 1 for unit rate. And by dividing the first number by the second number, that's how we do that. All right, now we got some percent problems. What percent of 6 is 2? So what percent is x? Of means multiply. Of 6 is equals 2. Well, how do I solve for x times 6? Undo multiplying by 6 by dividing by 6 on both sides. X is going to be equal to, that's going to be 0.33 repeating. Now, is that the percent? Does 0.33% sound right? Does 2 sound like it's 0.33% of 6? No, it's actually going to be, or move the decimal 2 to the right. Percents need to be moved 2 to the right when you solve them like that. It's going to be equal to 33%. Okay. All right, last percent problem. We have 65% of 500 people like the Packers. How many people like the Packers? So 0.65, convert the decimal to a percent to a decimal, of 500 equals how many people? So we're going to just multiply 0.65 times 500, which is going to be equal to 325 people. Okay, almost done. We got 4 more problems. Thanks for sticking around and watching this. I appreciate it. Hopefully this is helpful. All right, number 21. It says, use unit analysis to convert the following. Show all work to show units canceling. 21 says, turn 32 ounces into pounds. When you know that 16 ounces is 1 pound. So we're literally going to go with what we start with, which is 32 ounces. Put it over 1. We're only converting one We're only converting 1 unit, which is ounces. If you do like ounces per day or something, you would put that on the bottom, but we're just doing 32 ounces, okay? So we're gonna go like this, and we're gonna line up our units that we want to cancel diagonally. So am I gonna put ounces on the top or the bottom if I want them to cancel? Well, I'm trying to go to pounds, so I'm gonna put 16 ounces on the bottom because they will cancel then, and 1 pound on top. Ounces are gonna cancel. Now we're gonna multiply straight across. 32 times 1 is 32. 1 times 16 is 16. 32 divided by 16 is going to be 2, and it's going to be 2 pounds. Okay? So the units you want to cancel, put them diagonally, and then just multiply straight across the top, straight across the bottom, and then you're going to write your final units. Number 22, turn 21 inches into centimeters. So it's only 1 unit we're converting, so 21 inches over 1. And then we're going to put, now we want to cancel inches and go into centimeters, so I'm going to put inches on the top or the bottom. I'm going to put inches on the bottom, and I'm going to put 2.54 centimeters on top. Inches are going to cancel. Multiply straight across the top, which is going to be 53.34 over 1, which equals 53.34 centimeters. All right, easy as that. Last 2 examples, which are the hardest problems on this worksheet, but stick with me and we'll get through them together. All right, so it says the perimeter of a rectangular sandbox is 30 feet. The length is 1 less than 3 times the width. Find the length and the width of the sandbox. All right, well, let's draw a picture here. Okay, so it says it uses the width to describe the length. We're going to just call the width like this. And the length is going to be equal to something, okay? So the width is using the length to describe the width to describe the length. So the width is just going to equal the width, right? But the length, what does the length equal? It says the length is 1 less than 3 times the width. So 1 less, remember, is minus 1, and that's going to go at the end of whatever is written here, which is 3 times the width. So that's going to be 3w, right? So the length is, if it's 1 less than 3 times the width, that's going to be 3w minus 1. Okay? They're using the width to describe what the length is equal to. So the length is going to be equal to 3w minus 1 for both of these. And why do we do that? Well, the formula for perimeter of a rectangle is 2L plus 2W equals P, right? The problem with that is that we can't solve something with 2 variables. So if we did 2L plus 2W equals 30, which is the perimeter. Well, how do you solve that? If you solve that, you would get L by itself, which you would still have W to deal with, which is kind of clunky. So what we need to do is we're going to take that L, we're going to replace it with 3W minus 1. Then we can solve that because we'll have one variable which will just be W. So we have 3W minus 1 plus 2W equals the perimeter they said is 30. Okay, now we're going to solve this for W. We need anything to distribute here? Yeah, we got the 2 to both of these. So we got 2 times 3W is 6W. Minus 2 times negative 1 is negative 2. Plus 2W equals 30. Anything else to distribute? No. Any like terms? Yep. 6W plus 2W is 8W. Minus 2 equals 30. Now we need to solve for W. We need to get rid of that minus 2 by adding 2 to both sides. So 8W is going to equal 32. Divide by 8. W is going to equal 4 feet. And we're almost done. We know W equals 4 feet. We also know the length equals 3W minus 1 because we found that out. So we're going to plug in 4 in for W. So 3 times 4 minus 1. So L equals 12 minus 1. So L is going to equal 11 feet. And there we go. Okay, the sum of 3 consecutive odd integers is 99. What are the 3 numbers? Let's use a nice light blue here. Okay, so consecutive odd integers. What are some consecutive odd integers? That would be odd numbers that are in a row. So if we do 11, 13, and 15 are consecutive odd integers. Those are probably not the numbers. In fact, they are not the numbers. But I'm using these numbers to come up with a pattern here, all right? I'm going to call the smallest number x. I'm just going to call smallest number x to give us a frame of reference. Because I could call this number x, y, and z, but if I do x plus y plus z equals 99, I can't solve that because I have 3 variables. I need 1 variable to work with here, all right? So my question for you is, how do we get from 11 to 13? What do you do to get from 11 to 13? Well, you add 2, right? So we could say that 13 is actually 11 plus 2, or x plus 2. Okay, we're doing this to figure out a pattern. We actually don't know what the numbers are. We're going to come up with a pattern here. How do I get from 11 to 15? Well, that's going to be 11 plus 4. Or, if 11 is x, then it's going to be x plus 4. Okay, so this pattern is important. It's going to help us figure out how we solve for the rest of the problem, all right? So instead of doing x plus y plus z, we can do x plus 2 plus x plus 4 equals 99, because the sum of them is going to equal 99, and we have all x's now, so we do know how to solve when there's all 3 variables that are the same. All right, anything to distribute here? No. Any like terms? Yes, we have x, and x, and we also have 2 and 4. What is x plus x plus x? Well, that is 3x plus 2 plus 4, which is 6, equals 99. Any other like terms? Nope. Anything? Now we got to get all the x's, get the 3x by itself, so how do we do that? Subtract 6, so we get 3x equals 93. Solve for x by dividing by 3. X is going to be equal to 31. And then we got to just count in a row. So 31 is the smallest number. Count up by 2. X plus 2 is going to be 33, and then 35. Those are the 3 numbers that work. So which is pretty cool, because we take a long time to guess what numbers work, and this way we use algebra to solve it a lot quicker. So, all right, that's it. Thanks for watching. Have a great day. We will see you soon.